Ladies and gentlemen, please welcome Vice President, VMware Technology Alliance, EMC Corporation, Chad Sakash, and
Hello,
Vice
everybody.
President, Solutions Acadia, Phil Harris.
How's everyone doing? Good. It's going to be an awesome session. Lots of cool stuff. I know that I appreciate everyone being here. Just before we get started, quick show of hands. How many of you are Cisco customers? How many of you are EMC customers? How many of you are VMware customers? So first of all, thank you to everybody. Always important. The second thing is the fact that almost everybody all raised up their hands is why we're here and why we're doing what we're doing, as well as to accelerate that journey. But I know that we're going to have to accelerate through the deck because we don't have much time. So Phil, let's get this show on the road.
Thanks, Chad. And I'd like to wish everyone welcome as well to the session. Phil Harris, VP of Engineering at Acadia. You'll notice the difference between Chad and I. He's the quiet, unassuming one. I'm less so. I'm going to start the session this afternoon. I just came back from Maui last night, so it's sometime, somewhere.
That's a rough life, Phil.
It was a red eye. So I'm going to start the session by going through what is Vblock, the architectural principles, how we came to this position, and then Chad's going to go through some of the really important demonstrations of what we're doing in terms of solutions that we're building on top of the Vblock platform. And as we go through this session, hopefully we can deliver some of the information you guys are looking for about what Vblock really is, where it came from, the methodology, the thinking behind it, and what we can do with it. Okay. Now, I do believe that every good presentation needs a slide that basically states the bleeding obvious. So this is my slide that states the bleeding obvious. Yes, that today's IT infrastructures are becoming very, very complex, that the whole mechanism and life cycle between procurement, design, architecture, deployment is becoming one of those things that's a driving force behind the basic change in acquisition and deployment of IT that we're calling cloud. Now, before we get into the whole discussion about cloud, and I'd like you to all count the number of times you see cloud on these slides, and we'll have a test at the end. It should be a large number. One of the things we should understand is why is this important right now? And it's not just because the technologies are becoming available that allow us to exploit this new paradigm in acquisition and deployment and consumption, but also what are the problems we're really facing today? Just to give you a little bit of history, and I'm not going to spend too much time because I'm going to get a bright flashing light from this guy down the front row saying I'm going too slow if I don't say this too fast. When we started Vblock started as a reference architecture about 2.5, 3 years ago. And a colleague of Chad's, a gentleman by the name of Jim Dowson, who's a dear friend and colleague, and we roamed around the US and other parts of the world talking to customers about what was really going on inside the IT organizations. And one of the things we found was interesting. Anything up to about 28% of IT budgets were consumed with non-recurring engineering costs. Those costs that are just sunk costs, they're lost. You'll never get them back again. And only about 28% of that 28% ever realized an IT project that was truly successful in terms of the fruition of what the outcomes that were initially expected. So we're losing a lot of money. There's a lot of complexity. And if we can actually now crystallize what we've learned through those years of deploying IT and take out that non-recurring engineering cost and now start deploying these new consumption models, we think we can drive deployment, we can drive business alignment, and we can really drive the true optimized exploitation of the technologies we now have available to us. So we need to think about this differently. We need to think about not only the technology differently, but how you acquire it, how you deploy it, how you service, and how you support it. This is a full life cycle discussion we have to have. And by the way, Chad's not just going to stand there. He's going to add color and context throughout this presentation.
You couldn't stop me in a million years, Phil.
This point to make. Okay, so what's one of the things that we really face as an interesting discussion? And I tend to think of things in somewhat abstract ways, so bear with me a wee bit here. Workloads have geometries. Any application or workload or system has a geometry. It has certain parameters. It has certain operational characteristics. It has certain ways we can measure, we can scale, we can identify. Now, the problem we have is the way we then build architectures to support these workloads tend to be isolated. Mm-hmm. We tend to find, and we did some studies on this one, And this is nobody's fault. This is a combination of lines of business making purchasing decisions, different philosophies around architecture, different technologies at different points in the maturation of those workloads. Some of those workloads written in COBOL that are still sitting there in those data centers that, have been there since before most of us were working or making a living out of it, or some of us were. Those things have had a whole life cycle where the architectural geometries have changed. Now, one of the things that virtualization can truly allow us to do is to classify workloads and start thinking about these geometries. And instead of building isolated silos of architectures, we can now start shaping these workloads, these geometries, into containers. We all use this word a lot. We understand that. But truly the use of this is how we can start thinking about these workload geometries and move them into a consolidated infrastructure that truly gives us higher densities, higher consumption, higher availability, higher performance operational metrics.
The thing that I would just add is, it's not just us. As we went around talking to customers, it's true today. If you ask how many customers are trying to hyper-standardize, a whole set of infrastructure so they can just plop on additional workloads with all these different geometries with common infrastructure, it's pretty consistent, right? But everyone was homebrewing and trying to home construct these things that involves a lot of work.
Right, and I think the important thing here is, and if you look at the examples, and obviously this is not authoritative or comprehensive, it's just an example to be representative or illustrative. One of the things you also have to think about is, what are the different security parameters we have to think about? What are the different profiles of the users of the workload? What are the different characteristics above and beyond just a simple ability to get a bunch of boxes into a FedEx container, which is effectively what we're thinking about. In fact, if you really think about the logic behind this, probably the guys at FedEx probably thought more about this than any of us have ever thought about in terms of getting the right size box and the right size cart. Well, when we think about this, we've also got to remember security, operational classification, prioritization, the ability to really treat still every workload as individually classified as if it was in its own standalone architecture is, of course, of paramount importance as well. So, Vblock is a set of packages that form an architecture. Now, Vblocks themselves have standalone characteristics. They have scale, they have capability, they have performance. In of themselves, they represent a unit of assembly that allows us to deploy highly virtualized environments rapidly, predictably, and at scale. But to get scale, you need to think about how you grow an architecture beyond just the four walls or the top or the bottom of the racks. You need to think about extremely clear and understandable metrics about how you can rapidly deploy these scenarios. The pre-integration part's interesting. A lot of customers will say to us, well, hey, guys, we can do this. You can. That's that non-recurring engineering money we were speaking about earlier. But the difference is, by the three companies, Cisco, EMC, VMware, coming together and designing Vblock, from the get-go at the engineering level, allows us to truly take the input from the R&D and the development organizations and pre-integrate these packages with far better clarification or clarity about how they'll operate and what they'll do in terms of these different workload parameters. So I think the important thing here is the pre-integration and validation gives you the certainty and the surety that when these workloads are being deployed, you know exactly how they're going to operate. Service levels are one of the most critical aspects of how we think about the deployment of Vblocks. In fact, one of my very original slides, and some of you guys in the audience may have seen these, actually had simply two axes, and there's a version of this slide later in the deck that basically had capability and performance. And the different types of service bands that you could deliver based on the infrastructure became the critical driving point. It wasn't just how big was that container. Scale is only one component. And by the way, scale and size aren't the same thing, right? Just because I can put 50,000 VMs into a container doesn't mean I've got scale, I've just got size. Scale has implications of security, as we mentioned, high availability in the general sense. So we have to think about not only how we build these things to be very large, but how we scale them and be consistent with those service levels. And the last point on this slide about security is the interesting one that I kind of alluded to previously. We've got to think about how multi-tenancy, for example, isn't just a facet of service providers, quite frankly. When lines of business were building their own infrastructure, paying for their own infrastructure, servicing and supporting their own infrastructure, you basically had multi-tenancy at a data center level or at an architecture level. I once said to somebody, the perfect multi-tenancy system is where every customer gets their own data center, they just don't have to run it. But of course, the economics of that don't work out. The economics is we need a bring things together in a common unified infrastructure, but segment them and provide policy-based access and policy-based deterministic behavior that we can identify. So we'll talk about this more in a few minutes. I'm going through because he wants to get through his presentation.
I'm like, they're so cool, man. They're so cool.
He just says this. Okay, so Vblock has to be standards-based, though, which means that we are looking to make sure that we can provide the capability to have the standard infrastructure that you have today redeployed on this infrastructure that we're deploying called Vblock without you having to go through the pain of multiple certification processes. We're taking that on board. So we do the integration work with the ISVs. We do the integration work with all the service and support components that we provide to you as a service. And we do this across a broad range of operating systems and a broad range of application types. And I think it's important to understand that from this perspective, we really believe that because we're taking a very tightly integrated infrastructure package and we're deploying this for a broad range of workload types, we could be not only deterministic, as I mentioned before, but as new workloads change their type, change their geometry. It's interesting. One thing that cloud has done is woken up SOA people. People who were thinking before that SOA was good for the enterprise, but it never really panned out. For the cloud, it's actually much more interesting. Reusable components can be used across applications or systems or processes. So our ability to be very standards-based while still very tightly integrated, I think is a great benefit to you as a customer. Okay, so very quickly going through the benefits of Vblock from an ultra-standardization perspective. The gentleman I mentioned before, Jim Dowson and I, we went to this customer just outside Chicago, and we had this conversation. I actually used this very slide, and I built this slide on the plane ride over. And one of the things that we got talking about was, well, how do you do capacity planning in this new world? How do you think about VMs being deployed? It used to be easy. You knew the size of the systems, you knew the size of the disk arrays, you knew the size of the infrastructure. You could kind of figure out what your data center would look like. But virtualization was making this cloudy, no pun intended. The reality was, however, what if we could get to the point where Vblock was so deterministic for an operational perspective that the very floor tiles that those racks would occupy became your point of scale or your deterministic point of capacity planning? What if you could say, in a 10,000 square foot, 1 megawatt data center, I know exactly how much capacity I've got because those are the physical dimensions of that container. And from that, I could be extremely deterministic about what I could provide from a platform perspective.
One thing that I'd add is that as we went through that process, we found that if we tightly coupled the system, tightly designed the system, we could have much higher VM density per unit floor tile, per unit power. So the more tightly we can integrate these things from performance and design standpoint, the more efficient you are, not just in terms of simplicity of scale, but also simplicity and density of total data center efficiency.
You've all heard the urban myth, the 15 to 18% virtualization wall that people hit. It's not such an urban myth. And it's not an issue of technology. It's an issue of process. It's an issue of complexity. It's an issue of change management. If you can be that predictable, we're now seeing virtualization levels in the same customer we spoke to was going through a V to P exercise about a year and a half ago, which twisted my head even more than it's already twisted. Because it was like, well, why? They couldn't get to this point of deterministic deployment. Now, completely changed that around, and they're basing the capacity management of that data center on the number of floor tiles they can occupy. We're now getting 80% virtualized workloads, and about 82% of that infrastructure is actually utilized in production environments. Most customers who are doing very well with the utilization of infrastructure struggle to get above 50%. The other thing at the bottom of this is the notion of deterministic fault and security isolation. One of the things we really felt was important was if you were going to have this standardized infrastructure, we couldn't allow catastrophic failures within the Vblock to have the domino effect around the Vblock, or conversely, catastrophic failures outside of a given Vblock affecting the workloads, because the Vblock itself represents both that logical and that physical point of isolation, allowing you to be very deterministic again, that same word, about how failures will occur and could affect running workloads in your data center. So I think that the predictability of this is one of the most, I think, beneficial aspects of Vblock over and above the tight integration of the technology that allows you to get access to this technology faster than you could do it any other way. So at this point in time, and this is kind of the newer version of that slide I mentioned a few minutes ago, there's 3 Vblock types. Now, there's an old engineering maxim that says you never start numbering with a 0 because you want to go smaller. So what do you do? Make it 0.5 or -1? I mean, it's
so we've got a little bit of a problem on that.
So we may have created our own little bit of a problem here, but we'll get through that. We'll just change it to.
That's just marketing.
We'll put another number in front of 0, and that's how we'll solve that problem. But anyway, right now we have 3 types of Vblock. And the types are very important because they aren't just small, medium, large. You buy T-shirts that way. You don't buy Vblocks that way. If you want to go buy T-shirts, small, medium, large is probably a good way of doing that. Vblocks, not such a good idea. Service bands, capability, performance, and serviceability are the things that really truly distinguish the types of Vblock which we'll speak about. Now, once you can be deterministic, again about those things, you can now start thinking about the size in terms of the deployment of VMs you can execute. So, I don't tend to use slides as much as our friends in marketing would like me to, so I'm going to say this, because it's got cloud on this slide, so you're up to about 32 if you've been counting right now. I think that's about the right number at this point. If you think of Vblock Type 2s as really your scale-up model, this is the model of Vblock that truly thinks about very, very high density, high availability, high capability within the Vblock itself. So if you're looking for a situation where the Vblock itself needs to have a myriad of features that allow extremely predictable performance, high capacity, high I/O throughput, high compute density, high disk density, Vblock 2 gives you that within the Vblock. Now, that is in of itself an interesting paradigm for certain types of workload that need to have all those resources immediately available to the workloads themselves. Mm-hmm. As opposed to other workloads where maybe you can distribute your risk, distribute your performance, distribute your capability across multiple Vblocks. For that, we have the Vblock 1. Vblock 1 is your scale-out model. So if you're building cloud infrastructures where scale-out matters, where maybe you've got very similar workloads, but lots and lots of them, that you want to distribute your capacity, distribute your load, Vblock 1 is your option. Again, highly matched components between compute, network, storage, and virtualization, but really optimized in that large-scale deployment for similar types of apps that would have similar types of capacity requirements and feature requirements across the data center floor. Then we have Vblock 0. Some people call it the starter kit, some people call it the entry level, some people just use it for a myriad of different reasons. Mm-hmm. Some of it to simply understand how do I start breaking into this new environment. You can also use this for other capacity types of deployments such as test and dev, and other things where you want to have a smaller footprint that is representative of all the same ratios of performance and matching of capabilities that the other Vblocks would give you. So we have a range of Vblocks to start with. Now, my team, and I own engineering at Acadia, already have multiple new Vblocks on the roadmap. We'll talk about roadmap a little bit later. And we're already thinking about how we scale to new types of Vblocks going forward for different types of workloads. But we do take this very seriously that we're going to come out with every Vblock will be highly certified in terms of its operational characteristics, the workloads it runs, before we bring them out to the public. But we're doing this at an extremely fast pace. So this is what we have today, but we're building upon this. So, management. I'm going to take a few minutes because I want to get Chad a chance to talk about his slides.
And why describe it when I'll show it?
He's going to show this, if you didn't catch that bit. But very quickly, let me just say one thing. The one thing about management is how tightly integrated the infrastructure is, but how extensible our management framework is. This is a differentiator, we think, which is fundamentally important. What we have done is looked at the Vblock now as a point of aggregation of events, of configuration, of monitoring, that allows us now to have a very straightforward set of, or API, that allows you from, in this case, tightly integrated into vCenter and vSphere all the way up to Cloud Director, that allows you to have one unified stack, which is built on open APIs. We don't believe in closed APIs. We believe this is where we get value in the long run, is to have open APIs that we publish and we describe to you guys. But Chad said he's going to show you this. But management is an important aspect because where we'll be extensible, our competition tends to be closed. And we see that as a big important differentiator for you as customers. Security, and this will be the last slide. Before I get into the detail of this very colorful, busy slide that has lots of moving parts, and if it had bills, I'm sure it would, let me just say there are three ways of looking at security. What's in the Vblock, what's on the Vblock, and what's with the Vblock.
Yep.
And that's a very strong metaphor we use inside Acadia to describe how we think about things like security. Internally, every interface is secured from a management perspective, from an operational perspective. The workloads that run on top of the Vblock have security in terms of segmentation, policy-driven access. And around the Vblock, the with part, we can now have an extensible Vblock security model that allows you to build an ever-increasing perimeter-based security model that allows you to have the correlation between user security all the way through LAN security and VM security, all the way to the physical infrastructure itself. So management and security, we think, are two of the most critical elements as you start deploying cloud to your customers, being paying customers or internal customers, that allows you to be very, again, deterministic in how these things will work.
Both the management topic and the security topic are something that is not a bolt-on. It's built into the design, philosophy, thinking, day in, day out, about what do we want to do with Vblocks, what do our customers want to do. The management model, for example, that idea of openness, it doesn't mean that the sub-elements of a Vblock don't have open APIs, they do. But in the same way that we're moving up the level of management to the entire Vblock stack, you want an open, extensible API for the entire thing. And
That's
likewise,
right.
The security model needs to be thought of both, built in, built on, built around.
I came up with this saying, and this will be my last word because I've got 5 seconds to say it.
Take your time.
Vblocks can represent a complete greenfield, or the green patch in the brown field. And quite frankly, from a management and security perspective, it's much more likely will be the green patch in the brown field.
Right.
So the ability for us to integrate seamlessly into your existing estate from a management and security perspective is keenly important to us. So to Chad's point, we will provide that single point of aggregation from an infrastructure management perspective up to higher order orchestration layers such as Cloud Director, but still maintaining the veracity and the availability of all those sub-component management points. Again, extensibility is the key here. Our management philosophy is one about openness and extensibility, not monolithic closed systems. On that note...
You bet. So wait till you see what's next.
I'll hand the pointer to Chad.
So, and I think the thing I want to talk about is now the built-on Vblock, right? So, and this is an area that Phil has a peer, Todd Pavone, who's very focused on the solutions that are built on top of Vblocks. So the solutions that have been validated are very broad, and we have no time to give every one of them, but I want to highlight a few examples. The first one was solutions around SAP on Vblock. So many customers want to deploy mission-critical applications. How do you do it? How do you scale it? How does the configuration work? So, boom, document and detail. Another example, how do you deploy View on a Vblock? What sort of scale can you reach? What sort of configuration? What do the economics look like? Document, detail. How do you back up and recover a Vblock that has thousands, 6,000, 10,000 VMs on it? That's something that we need to think about as well. Not only how do you do business continuity, how do you do DR, but also how do you do basic backup and recovery and do it at a degree of scale and management model that works. Again, detail and document. And then a great example around how do you federate Vblocks that are running Exchange, SQL, Oracle, SAP all at once, SharePoint too, between Vblocks using things like OTV, using things like Vplex. Now, the thing that's interesting about this is, these are a small set of the examples that exist. But when people were talking about, should I, can I construct my own integrated, hyper-standardized stack? The answer is yes. One customer that I know that's extremely advanced embraced that idea 3 years ago, even before we started to do it 2 years ago. And, their example of a Vblock-like thing with its name, right, which I'm not going to throw out there, but their comment was when we rev from version 2 of that thing to version 3 of that thing, just the testing will cost us somewhere between $1 and $3 million worth of that no-value recurring engineering cost, right? That's even before you get to the question of the stuff that runs on the Vblock, like these solution docs. Now, the other thing that I want to highlight is customer examples, because we're doing this not just as a scientific exercise, we're being driven this way by the industry and by our customers. So 2 quick examples. One, CSC Australia. So So CSC Australia is a fantastic VC partner. They're building their cloud go-to-market based on the VC efforts that we're doing in conjunction with them. It's helping accelerate their cloud go-to-market. And, it really helps them not only continue their leadership position, but accelerate the whole public and private cloud model in APJ. And I think it's a great example. You guys here in the audience. So if you don't, just stand up for a second. So first of all, thank you as a customer. If there's any other folks that are, service providers and want to talk and hear experiences, from a partner that has experience, thank you very much, guys. Come on up afterwards, and you can talk to them. Another example is Alcon. So Alcon is a customer who is a Vblock 2 customer. They have 4 Vblock 2s. One thing that, they're in the eye care industry, and they're a global enterprise. And, there's a lot of variation, just like many, many enterprises, between what runs in one part of the world versus what runs in another part of the world. Many customers that we're finding are actually looking at Vblock as a way to help accelerate their own hyper-standardization opportunities. In other words, if the model works here, why can't we just take that unit of construction and use that as our mechanism to drive uniformity through our organization? They've seen huge benefits from a CapEx and an OpEx standpoint in terms of cable reduction, in terms of data center efficiency, all of those sorts of things. So Alcon folks, I saw you guys at the front, if you don't mind standing up. So thank you very much for being a VC customer. Again, if you're an enterprise as opposed to a service provider, another great set of folks to talk to. Again, thank you guys. Much appreciated. So the other thing that I think is an interesting idea is this question of life cycle and roadmap. So obviously people come to VMworld to kind of see the future a little bit, but there's also a critical idea in part of this process, and actually Phil's job in the VC effort is actually he's responsible for the engineering and life cycle of the Vblock. So this is his baby, right?
This is my baby, yes.
So the life cycle question is how do we rev the Vblock? How do we design those new variants for focused specific use cases? When is it time to make the next major rev of the one for a targeted use case? And I think it's a very interesting thing, right? So basically where we are now, you can kind of see on this timeline. And no one's going to be able to read that.
But the legalese at the front, the top right-hand corner is the important point. These are
exactly.
forward-looking
statements.
And so, holding my feet to the fire is an okay thing.
Right.
My boss, Michael Capellas, does that.
The 2010 version of the Vblock, because, we started this back in 2009, is focused on all the stuff that you guys have seen come out this week. vCloud Director is a huge part of that, right? The whole idea of unified infrastructure manager from EMC is a huge part of that. The higher density UCS platforms are part of that.
Right.
Native FCOE to take out and squeeze out even more elements of the cost models are part of that. But the thing that I think is interesting isn't just those things, as well as some of the more forward-looking things. So there will be a Vblock 2011. And while we're not going to go to any of the details publicly, again, if you get Phil and I afterwards and we go for cocktails, that might be
the bar of the W is probably a good place to find us.
But, the things that are the goals are to make the idea of elasticity and fluidity be something that moves outside the Vblock itself. We're already very, very fluid within the Vblock, but how do we federate? How do we make that idea more open and more broad? And again, this is a common joint shared vision between VMware, Cisco, and EMC. So who here was in Paul's keynote? Right? So you know how he drew the private cloud and the public cloud and private to private cloud federation and building hybrid cloud models? Those are the things that are basically the design goals and design targets of the engineering efforts across the teams. But the thing that I think is interesting, Phil, is actually how you, in your role, drive the integration effort and how you work with VMware, EMC, and Cisco as contributors.
So very quickly, I'll just take a couple of seconds on this one. So I have basically a couple of different metrics, the way that Michael Capellas, my boss, measures me. One of them is I will have capabilities that the parent companies have on their roadmaps at the same time in a release cycle as the parent companies will, but we'll have integrated them, we'll have done the testing, the certification, the deployment guides before they hit the street. So we'll already have had that. So we work across a number of my guys in the room today, from a product management level, looking at every roadmap of every business unit or technology group within the parent companies. Mm-hmm. And we're continually working with those guys to think about forward-looking, how we take the right capabilities. Now, there's not everything that every parent company is going to bring to market that's necessarily relevant to Vblock. You know, the Linksys part of Cisco may not necessarily get into Vblock 2011, maybe 2012.
That'll be a Vblock minus 25.
Well, I do have 2 Vblocks in my garage, so they are becoming more consumer-oriented. We just haven't got quite to the point of packaging that way yet. My wife will tell you about that. But the point being is that, and one thing I would say is that Vblocks that are named after years, a bit like starting with 0, our friends up in Redmond, Washington learned what it's like to actually name a product after the year it's supposed to release. You tend to get a little bit behind that, so we'll look at that one. The point being is, though, roadmap integration is a critical part of what my group does, and that's the way of ensuring we have this tight integration.
The thing that's interesting, having seen that from the inside, is it also forces a tight interlock between the individual parent companies' roadmaps, right?
Right.
So it accelerates or decelerates things, and one thing that you see is it's actually tightly coupled with the cadence of VMware's release schedules, because VMware plays a critical piece in this whole architectural model. So lots of coolness. Again, cocktails in the evening, and you'll get everything from 2011 until 2012. Lawyers, I did not say that. That cut from the video. Roger. Okay, so a few demonstrations. So, you know, again, it's a chattism that you can't do a session without demonstrations, right? First one is this idea of vCloud in a box. So if you take a look, this is EMC Ionix Unified Infrastructure Manager. So this thing, what we're going to do is we're going to go through a bit of a scenario. If you saw this, we did this on stage in the VE session. I've compressed it down here a little bit. You can see that I can see a California vBlock and a Atlanta vBlock in a single screen, and I can see pooled capacity by blade and by storage and by pools of network attributes across multiple vBlocks. The thing that's important is it changes the provisioning model towards creating services. So let's say Acme Corporation is one of the tenants on a vBlock. Let's create a service for them. That service basically is the constituent of all of the elements of a vBlock, right? So it obviously needs to consist of what build of vSphere are we going to put on it, what vBlock is it going to reside on, what are the characteristics that we need from a server, network, and storage standpoint. But the key thing to note is that the idea of, like, for example, UCS service profiles, right? You know, we're taking that up one level of abstraction. Because here we're not just talking about making the blade, name and the network name a pooled attribute. We're turning it into the entire service. So we're saying, look, this service is going to consist of n servers that are in the gold, silver, or bronze pool, right? And where they're going to get pulled out and provisioned is something that the Unified Infrastructure Manager is going to do and manage at the pool level, right? Likewise, on the storage side, it'll automatically create, obviously, the boot LUNs that the ESX hosts are going to need. It'll create the VMFS data stores. And UIM's roadmap will also extend off to include NFS-based models as well, because today every one of the vBlocks can be in both mixed block and in NAS models. So here I'm saying, hey, the service profile is a little bit different than the baseline. It needs to have an additional big data store out of the box that it's going to use. But there's key elasticity that's built into this model as well. So, the number of blades and storage and capacity can be fluid. Now, what that means is that you no longer provision hardware, but move to a model of provisioning services at the physical infrastructure layer. So you're basically taking that vBlock standardized infrastructure element and you're saying, hey, I'd like to provision that service, which I actually just hit that button, and boom, it's now going through and it's provisioning every single element up and down the entire stack. Deprovisioning is also something that this will automate because people need elasticity. Now, ultimately, this gets consumed by a multi-tenant presentation model where it's infrastructure as a service. So this is using vCloud Director. My team, for example, and the VC Coalition team, we actually use this to support ourselves in the field. So what I'm doing here is I'm saying, hey, let's create a new tenant, Acme Corporation, right? And what do we need to do to stand up that service? So remember, underneath the vBlock is now going off. It's creating all of the underlying vSphere resources. And what we're going to do is we're going to say, let's create a new tenant. The tenant is going to run on top of this common infrastructure. How do they want to authenticate? Then let's create an administrator for that tenant. After that, that administrator can actually manage their own stuff, right? And create more user accounts as needed. So again, this is something that isn't done by the end user of IT as a service. This is actually done, we're creating it once for this particular tenant. So Wile E. Coyote is the natural name of the user if they're going to be Acme Corporation. There will be no giant anvil that lands on my head. And then you can say how much capacity are they allowed to consume? What are their quotas and resources? And how can they manage catalogs? Now, earlier on, you'll notice that one thing that we talked about was setting the quotas of how many VMs they can create and what the storage profile is. There's a lot of additional information here that can be set up for this tenant, right? What's the maximum deployment time for a VM? How long should it be retained on storage? How much are individual tenants allowed to provision themselves? And then how can they use the storage and compute capacities that are being provided, again, underneath on top of a Vblock? Very, very cool stuff. Very, very simple. And that then allows you to create these virtual data center constructs, right? So this combination of creating elasticity at the physical infrastructure layer and then the same sorts of concept exposed up at the virtual layer on up is a real end-to-end kind of vCloud in a box. Here what we're doing is we're saying, how much memory are they allowed to use? Is it a pay-as-you-go VDC or is it a fixed allocation VDC? Lots and lots of capabilities, including also total taking the ideas of security and network segmentation out to a much, much higher extent in the stack. So again, it's not just about the physical infrastructure. It's how does it actually get consumed by the end user at the top? As they go in, the question is this an extension of your private cloud, or are you a service provider that's creating a public cloud offering where clearly you're going to need to think about things like NAT and all the network management elements that go along with that?
If I could just say one thing on that, and one of the things we're really trying to do is give you guys the ability to think about this in a hierarchical model. Mm-hmm. So you have as a provider your VDCs, you have as the organizations your customers would be the organizational VDCs. All the way through the application can now be thought of as a set of service pools that allow you to very clearly provide infrastructure capability, but also abstract it so the complexity of the underlying services doesn't need to be exposed to the users who only need to consume the services themselves.
And ultimately, the ultimate manifestation is just what I did in the demonstration. Boom, we just deployed the VMs. They're up and running. They're now consuming those resources. So simple, easy vCloud in a box, and that's one of the benefits of the fact that we're working together. We see vCloud Director coming. We're working on UIM. We're working on Vblock and how we tie all those pieces together. Next example is an interesting one, an enterprise application. How many of you guys are using Cisco Unified Communications? This is a customer. Okay, cool. So basically, this is an example where there's 30 million Cisco IP phones that have been sold, right? And they've got broad consumption of those resources. I'm sure you've all seen them in all those TV shows. Cisco does a fantastic job of product placement in those contexts. But it's also really cool. I love my IP phone. We're obviously a huge customer ourselves. And the question is that normally those are deployed in static physical servers. Check out this example. In this example, we've got a Vblock 1, and this is an example of a workload that's a good fit for a Vblock 1 type fit or a Vblock 0, where this infrastructure, where I've got all of the Cisco UC elements and the Exchange servers, all running on the same Vblock, could easily support 15,000 IP phones. Now, if that sounds very, very large, you'd be surprised. Even a mid-sized enterprise has lots and lots of phones all around there. But by the way, a Vblock 0 could do 5,000 IP phones easily, right? So the key thing here is that you can see we can drive this on the same elastic infrastructure that we're using for other things. And if you think about the first slide that we were opening where we said, hey, look, as opposed to deploying all of these weird little siloed things, right? Why would you deploy the Exchange servers over here and these servers are the Cisco, Unified Communications servers? What you want to have is a Vblock that you just put all this stuff on, right?
As an example, before I took the role at Acadia, I've been at Cisco about 16 years. And a lot of my work was writing iOS code in the early days and how you figure out how to do scheduling of very delay-intolerant or jitter-intolerant workload types like voice. And so the ability for us to provide a service pool that can definitively provide that service capability meant our voice guys now felt comfortable. And by the way, until this, they weren't so cool about running in virtualized environments.
Right.
This was an anathema. This was the antithesis. Voice was here, virtualization was here. This was an orthogonal problem set. Now, we can actually provide this capability with deterministic performance, operational characteristics, and it works very, very well.
And, I picked this one example, but, likewise, many of the customers, and there's a great There's a great example of a customer who went through a very extensive POC of SAP on a Vblock, right? So again, that one of the things that they thought was, they got a lot out of the whole exercise was the whole stack has been very beaten on. The team that's there in Santa Clara that is doing the systems integration work is not just integrating the hardware, they're looking at how these mission-critical applications go on top of the Vblock, right? So it's not just the reference architecture. The reference architecture is the beginning,
Yep.
right? So another thing that's interesting, though, is I'd classify these applications of SAP and the unified communications not as, they're applications that are not these new scale-out fluid models, right? They're more of a standardized, I know the Exchange server, I know UC server, how they're going to work. One thing that's very interesting is now you've got this elasticity that's been brought in at the physical layer all the way through up to the consumption layer at the top via vCloud Director. So let's look at the next example. How could you use this to power scale-out analytics? So let me give you an example for a moment. You've got your Vblock 1. It's sitting right here. You've got your Exchange 2010 Unified Communications on it. It's also powering a whole bunch of other stuff. But there's a little bit of squishiness in there. In other words, resources could be applied on demand to a variety of tasks, so things are moving around. It's cloud-like, right?
Squishy.
It's squishy. So the question is let's say that you're a major, any company, small, large, medium, one of the major things that people are looking for is how do I get business information, analytics, to answer fundamental business questions for me. And this is a whole new area of data warehousing and specialized vertical stacks just to go at this. We think that this can be gone at that vertical, that horizontal virtualized approach. And that actually gives you the ability to leverage that fluidity in the infrastructure to be able to scale up and scale down as needed. So look at this example. So this is actually done on a Vblock 1. This is the picture of the actual Vblock 1 that it was done on. You don't need to read all of the giblet details, but let's see what that enables. So as an example, there's a capability from EMC called Greenplum, which is a next-generation scale-out data warehouse. It uses what are called these segment servers and master servers to distribute doing the analytics, right? And it scales pretty linearly. So here what I have is I have additional segment servers that are sitting there idle, and then I've got another 32 segment servers that are sitting there idle. And you guys can probably see where this is going, right? The question is, hey, look, let's do some analysis of some data, right? And again, for those of you that don't do this day in, day out, it's a huge data set, 12 million rows. Let's say you're a cell carrier and you want to answer a critical question. Why do customers stay or why do customers leave, right? Is it caused by dropped calls? Is it caused by other things? Let's do something to try and correlate that data. That's business analytics. So let's run that workload, and how long does it take to answer that fundamental question, right? So it takes a certain amount of time with an 8-node environment. Now you take a look at it and you go, my Vblock 1 has the ability to scale out. I've got some resources that are idle, and I'd like the answer faster, right? Because now that I've got my first answer, now I know what the real question to ask is. So let's ramp up an additional another 8 segment servers. We do the data load and transformation, and then we go through and we say, okay, now let's ask another question, right? Now, in this case, what we did just to make sure that the comparisons were even was we asked the same query again. But you can see that what happens is that we're scaling up the computational capability, leveraging the elasticity that's in the infrastructure. So it takes a certain amount of time to do the queries for that. Now, as you move on, to the next level, let's dial this all the way up to 12, and add in another 16 nodes. And by the way, you could scale up and up and up and up. But the point also is that you could scale it down, right? So what we're doing is we're leveraging the extra capacity that's used as workloads vary inside the enterprise. We issue that same query, and again, for enterprises, any enterprise, small, large, medium, getting access to this business information is critical, right? So being able to ask fundamental questions and get fundamental answers is something that everyone wants to do. The net is it took us roughly 9 seconds to get the query with 8. It basically took us rough and tough 5 seconds if we had 16. And if you take a look as we scaled this up to 32 examples, we got it in 2.7 seconds. So you can see this idea of linearity of scaling and elasticity of infrastructure.
On one point on that one, I mean, you'll hear me use this term deterministic elasticity, which almost sounds an oxymoronic statement, because up to now it has been. It's been almost impossible to be elastic and deterministic. But this is what we can do now. One of the interesting things we can also do with this is we can think differently as how we distribute apps. Currently, the way we think about apps is, an app's getting really busy, let's just move that app somewhere else because it needs more capacity. Well, what if we can say we can move other things around now? Because we're deterministic enough, maybe there's other workloads that have different service levels. Maybe we should move those first, give this workload a little bit more scalability as it needs it up to the ceiling we provision for the service level, so that we don't become the inhibitor to the scale because we're now trying to do something fundamentally different with the infrastructure. So this notion of deterministic elasticity becomes a truly important aspect of what we can do here.
The other thing that I think is important and worth stating here is that the idea of the Vblock is actually the important thing, but the fact that the partners that are in the Vblock, A, share a joint common vision of where the industry is going, and B, are also leaders in our respective spaces, right, means that when we're working on things like how do we drive policy automation around the full stack, how do we take storage IO control and extend it out to full-blown storage DRS, how do we do all of those sorts of things of federating Vblocks and things that you've seen, if you put them all together in this context, what they represent is that each one of the contributors to the VC coalition effort are basically building their roadmaps against that joint common vision. So, I think the key thing that is an important kind of takeaway on this is a mantra for all three companies, and it's the guiding principle for the VCE effort. One thing that I think is important, and it's a good opportunity to come up afterwards if you've got, you want to talk to us a little bit more about it. The idea of Acadia is here to also accelerate that journey for our customers. But fundamentally, this whole journey and the VCE go-to-market is focused on these three fundamental principles. Number one, giving our customers the ability to have choice of applications that are things that they would normally deploy one way, they can now choose to deploy it a new way. The choice to be able to pick building their own private cloud, as an example like Alcon, working with a partner like CSC to help them build their own private cloud, or working with CSC Australia as an example to help them build their public cloud or even a hybrid cloud model. The ability to standardize, hyper-standardize on the infrastructure model. And one thing that I think is important to understand about that is that hyper-standardization as a design principle gives you a lot, right? I think it's an important thing to just think about because it streamlines the entire process. For us to, for example, innovate around things like UIM, we were talking about this right before we came in here, the only reason that we're able to build that thing as fast as we have is because it's not targeted at trying to orchestrate a bazillion different things. The only thing it orchestrates is a Vblock.
That's right, and we're in this great position where not only can we then have very closely aligned roadmaps, we can share resources. I can put my engineering resources into that team. They can work in the same place. We're actually cohabiting the same physical resources where the engineers are now, so we can get even more productivity out of this. Just say one thing on the workload types. I mentioned this geometry of workloads and how we can start classifying. There's a guy called Rich Taliber, who's our CTO at Acadia. Mm-hmm. We've got over 200,000 application workload deployment examples in a database that Rich has been deploying and developing. Tens of thousands of individual workloads, hundreds of thousands of deployment of those workloads. So we're going through a lot of effort right now to really help you guys. Now, will we have every example of every workload you guys have got exactly the way you've got it? Probably not. But we're going to have some pretty close directionality in terms of exactly how we expect those workloads to work in your environment, and then we'll work very closely with you. And that's what Acadia is going to do. It's going to come and work very closely with you guys so we can really tailor what those capabilities are. Because Vblock is standardization with the ability to be extremely flexible in its deployment. That's the whole benefit here. Not monolithic platforms that can only be deployed a certain way. And I think as you get that choice, control, and efficiency, we can truly drive up that consumption, truly drive up that efficiency.
And the efficiency point, just to close on that, not only do we drive efficiency through the process of virtualization, and not only do we drive efficiency out of hyper-standardization, we also drive efficiency through the idea of hyper-standardization on top of best-of-breed elements, right? So that allows people to start focusing on actually accelerating that journey that they've got through the various phases, no matter where they are, whether they're on the early phases of the journey, the middle phases, or the late phases. So what we wanted to try and do is just ask everyone here, please visit the VCE booth. There you can see, touch, and interact with a Vblock. You can talk to the teams that are there manning the booth. If you see people wandering around wearing those NASCAR shirts, with the logos, they're a great set of resources as well. Ask them about their experiences with customers. And if you're interested in hearing the perspectives from a service provider partner, again, thank you very much, CSC Australia folks. And if you're interested in talking to an enterprise customer, their experience, again, thank you very much to the Alcon folks. Thank you very much.
Thanks, guys.
Thanks for coming to the session.